Okay, I have had a request by a number of students to do some videos on factoring, especially because both of my classes right now in trigonometry and integrated 3 are both using factoring in order to solve the math that they're doing. So I'm actually going to do a 3 video set. It was going to be a 4 video set, but you'll see in a moment why I can keep it down to just 3. So I'm going to show you about 5 different examples here of factoring the common stuff out. Now, this is another way of saying factoring out the greatest common factor. But people seem to understand it a little bit better when we talk about factoring out common stuff. So the first problem is just a fairly straightforward, simple one. I just have to look at this and say, all right, what is the common stuff I can factor out here? Well, what's the biggest number that divides into both 6 and 18? It's 6. So I'm going to factor out a 6. I can't factor out an x because over with the 18 there's no x. So I cannot do that. So I have a 6 that I'm factoring out. So I put my parenthesis there. Okay, and I look at 6x divided by 6. So that's 6 divided by 6 is 1. And then we have the x. So I have 1x. Now I'm just going to write that as x because I really don't need the 1 out in front of it. But you should always remember that 1 because at times you may need it. I'll show you one of those in a moment. Then we're going to go plus because the plus is going to drop down. And then 18 divided by 6 is 3. Fairly straightforward there, not too bad. How about something like 15 x to the third plus 36x squared? All right, so we got to find the largest number that goes into both 36 and 15. Let's see, 5s, no, 15 definitely doesn't. 3 works, so we can factor a 3 out. But we also know that we have x's in both of these. Now, when you have x's in both of them, you have to look for the common, the greatest common amount. And that's another way of actually saying the smallest amount of x's. Because I can take an x squared out of an x to the third, but I can't take an x to the third out of an x squared. Okay, that may make sense. So in this case, the biggest amount of x's that I can take out of anything is x squared. So 15 divided by 3, 5. X to the third divided by x squared is just x. Another way to think about it is x to the third is x, and you're going to take an xx out of that, so you're still left over just 1x. Drop the plus sign down. 36 divided by 3 is 12. And we're taking x squared divided by x squared, or we're taking an x squared out of an x squared. So there's nothing else left. And that's that. The next one. How about something like 21x squared minus 6x. Scratch that. Minus 7x. I like that one much better. So minus 7x. So first step, we look at the numbers. Biggest number that we can factor out of 21 and 7 is a 7. And then we look at x squared and we looked at the x, the smaller amount. The x is the biggest amount that we can pull out. So we're factoring out a 7x. So 21 divided by 7 is 3. X squared divided by x is an x. Okay, just remember you're taking an x out of an x squared. Then we drop the minus sign. Now, folks, there's a lot of people that want to stop right here, even before I drop the minus sign down. They think that this is over with because the 7x is going to be gone. No, it's not. It can never be over with here. We put the minus sign there. 7 divided by 7 is 1. So we know that we have to at least put a 1 there. X divided by x, that's another 1. So it's technically 1 times 1. We got to put the 1 there. If you're wondering why we necessarily have to put the 1 there, well, all we have to do is say, let's distribute this and see if we can get back to our beginning problem. We should be able to. 7 times 3 is 21. X times x is x squared. 7x times a negative 1 is a negative 7x. Look at that. We got right back to our beginning problem. If we didn't, that'd be a really, really bad thing. All right, so almost there. Next problem. 5x squared minus 20. Now, I gave you this one really, really special because I wanted to make sure that I covered the stuff that I was going to talk about in the fourth video. And so I'm just going to cover it right here so that I don't necessarily need the fourth video here. So, the biggest number between 5 and 20, the big greatest common factor, is a 5. Let's see. I can't factor any x's out because 20 doesn't have any x's. So 5 divided by 5 is 1. And then we got the x squared, so 1x squared. Like I said, I'm not going to write the 1 out there. Minus 20 divided by 5 is 4. Again, some people are going to stop here. You really have to be able to recognize what this is. This is called the difference of perfect squares, or some people just call it the difference of squares. Either one is a good name for it. The reason why is difference comes from the minus sign. And x squared is perfect square because it's x times x. And a 4 is a perfect square because it's 2 times 2. So we need to factor this one more step. The 5 here is going to go along for the ride. Then we're going to put 2 sets of parentheses in here. We're going to put a plus inside of one of them and a minus inside the other. Then the square root of x squared is just x. The square root of 4 is 2. And we're done. That's done factoring. Now, the last one, excuse me, the last one that I kind of am going to show you leads into our next video. And the last one might look something like this. 3x squared plus 15x plus 18. And this is because this is a regular quadratic. We could just factor it using one of several different ways to factor quadratics. But the first step should always be factor the common stuff out. Because if we don't, then it's very, very likely that we will end up with some common stuff that needs factored out at the very, very end of the problem where most people won't do it. So it also makes the numbers a little bit nicer to work with, much easier to work with. So in this case, 3, 15, and 18. Oh, they're all factors of, well, the greatest common factor here is a 3. So I'm going to factor a 3 out. Now I can't factor an x out. Even though the first part has an x, the 15 has an x, but the 18 doesn't. So we can't factor any x's out. So 3 divided by 3 is 1. Then we got the x squared. 15 divided by 3 is 5. And then we got the x. And then the 18 divided by 3 is 6. Awesome. We factored out the common stuff. Now, to lead into the next video, we're looking for two numbers that multiply to 6 and add up to 5. So add there, multiply there. So let's see, 1 and 6, 2 and 3. That's pretty much everything that multiplies to 6. Oh, and if we're looking for ones that add to 5, 2 and 3. So I'm going to keep the 3 along for the ride. I'm going to put my parentheses down here. I'm going to put an X at the beginning of both of them. And I'm going to put a positive 2 and a positive 3. And I am done. They are factored. And I will pick up more about factoring quadratics in the next 2 videos, actually, but more about factoring regular quadratics like this one with a leading coefficient of 1. I'm going to do more of those in the next video. So, if you're still having difficulty with factoring out the common stuff, see me, and I can always try to give you some help and maybe even a few practice problems. All right, talk to you later. Bye-bye.